equal to integral over root of sine 2x cos 2x dx. As I told already, root term should be taken as t equal to sine 2x. Therefore, when you integrate, apply PTA rule, sine x you need to differentiate, so you will be getting cos 2x, and 2x when you differentiate you will get 2 into dx. Since we have cos 2x into dx, cos 2x into keep cos 2x into dx as it is and bring this 2 to the denominator, therefore dt by 2. In the place of cos 2x dx you need to write dt into 1 by 2. 1 by 2 is a constant, so I am taking outside. Root sine 2x is there. For that you need to substitute. Sine 2x is nothing but t, substitute root t. Root t is nothing but t power half. When you apply integral over x power n dx, that is x power n plus 1 divided by n plus 1, you will be getting t power 3 by 2 divided by 3 by 2. This 3 by 2, when you reciprocate and write, you will be getting 2 by 3. 2 and 2 will get cancelled, so you will get 1 by 3 t power 3 by 2 plus c. What is t? Substitute the value here. The next one, integral equal to integral over cos 2x into root of 1 plus sin x into dx. As I told, 1 plus sin x you need to take to be t. Therefore, when you take t equal to 1 plus sin x, when you differentiate it, you will get dt equal to cos sin x is nothing but cos x when you differentiate it. So, cos x into dx. Substitute cos x into dx to be dt divided by this 1 plus sin x can be written as t, therefore root t. Therefore, you will be getting dt is nothing but cos x dx, therefore you will be getting dt divided by root t. Therefore, root t can be written as what? T power minus half. Now, when you integrate this, you will be getting, apply x power integral over x power n formula, t power half divided by 1 by 2. When you reciprocate this 1 by 2, you will be getting 2 into t power half plus c. Substitute the value of t to be 1 plus sin x. Therefore, 2 into 1 plus sin x the whole power half plus c. The next question, homework 29th one, homework sum. There you need to take t value to be like this and proceed. 32 same as example 6, there they have given us tan x, here it is cot x, that's the difference. But I am going to explain that now. Just note down what you need to take as t and proceed. Keep it in mind, each and every step write clearly, understand and then write. It will be easy for you to do. Now 32nd, integral over 1 plus cot x into dx. This cot x can be written as cos x by sin x. That's what I have written here, cos x by sin x. Now after this step, after writing cos x by sin x, you need to take LCM of it. Therefore, you will get sin x plus cos x divided by sin x. Bring the sin x, that is, you need to reciprocate the same way. So, you will be getting sin x divided by sin x plus cos x into dx. Now, when I told whenever you have sin x plus cos x, something, you should take this to be t. When you take this to be t, what you will get when you differentiate this, you will be getting cos x minus sin x. But you don't have cos x, sin x only you have, but you don't have cos x. So, what we are going to do is, we are going to multiply and divide by 2. These are the few cases where we are applying like this. When you are multiplying and dividing by 2, keep this 2 here. This 2 sin x is nothing but sin x plus sin x. So, I am writing sin x plus sin x. After that, you are multiplying, adding and subtracting by cos x. When you are adding and subtracting, write plus cos x and minus cos x separately. That is, for this cos x and with this minus cos x. After that, split the integral. Sin x plus cos x, this denominator term is common for both. Therefore, sin x plus cos x divided by sin x plus cos x and sin x minus cos x divided by sin x plus cos x. That's what I have separated the integral derivative. And one more thing you need to keep it in mind is, this 1 by 2 is common for both the integrals. So, only I have given this bracket. Now, sin x plus cos x, sin x plus cos x will get cancelled. You will get dx. Now, take this to be t. T equal to sin x plus cos x. dt will be what? Cos x minus sin x dx. Check whether you have sin x minus cos x, but here is cos x minus sin x. So, what you can do? You can take minus sign of it and bring to this side. So, you will get sin x minus cos x into dx is equal to minus dt. So, in the numerator, you can substitute as minus dt divided by, this term is nothing but t. So, I am writing as t. This is nothing but when you cancel it, you will get dx. This half is common for both. Therefore half into integral over dx is nothing but minus x. It is minus log t plus c. What is the value of t? Sin x plus cos x. Just substitute it there. The next one, 33rd, it is same as example 6, only minus sign is the difference. 34th sum, integral equal to integral over root of tan x divided by sin x cos x dx. As I told in continuity and differentiability, whenever root term is there in the numerator, you need to conjugate. So I am conjugating here, root tan x divided by root tan x. Now root tan x into root tan x will become tan x. So write this root tan x sin cos x as it is into dx. Now this tan x alone I am converting into sin x by cos x. Sin x by cos x, this divided by cos x, you can bring it to when you reciprocate that, when you write, if it is 1 by 3 divided by 2, that can be written as 1 by 3 divided by 2. 1 by 3 into reciprocate this 1 by 2. Therefore, this 3 will come to the denominator. That is nothing but 1 by 2 into 3. This 3 will come to the denominator. The same way, this tan x can be written as sin x by cos x. Therefore, this cos x will come to the denominator. So, you will get cos squared x. So, this sin x and sin x will get cancelled. So, this cos 1 by, as I told, tan x if you have, now numerator should have secant squared. Therefore, cos squared x can be written as 1 by cos squared x can be written as secant squared x. So, take t to be tan x, dt will be secant squared x dx. Substitute the value of secant squared x dx to be dt and tan x to be t. Therefore, you will get root t. After that, this can be written as t power minus half into dt. After that, integrate and write according to the formula. The next question, 35th question is homework sum. Integral over log 1 plus log x the whole square divided by x into dx. In this, take t to be 1 plus log x, so that you will be getting 1 by x into dx to be dt. Now here also the same way, but there is a few change here. Here you will be taking 1 plus log x. Here you will be taking x plus log x to be t. Integral over x plus 1 into x plus log x the whole square divided by x into dx. Take t to be x plus log x. When you differentiate this, you will be getting 1. X when you differentiate, you will get 1. Log x when you differentiate, 1 by x. Then dx. After this, take LCM for this. When you take LCM, you will be getting x plus 1 divided by x into dx. Now when you see the integral, x plus 1 by x into dx, you can write it as dt. And this can be taken as t. This is x plus log x the whole square, therefore it will be t square. Therefore you will be getting this is nothing but dt and this is nothing but t square. Therefore t square into dt. When you integrate, you will get t cube divided by 3 plus c. Just substitute the value of t here. Now 37. Integral over x cube sine of tan inverse of x power 4 divided by 1 plus x power 8 dx. This is also one of the important sum. In this, as I told in the first class, whichever in bracket that we will be taking as t. These are some clues how to take t. Tan inverse of x power 4. Take t to be tan inverse of x power 4. When you differentiate tan inverse of x, you will get 1 plus 1 by x square. But here it is in the place of x, you have x power 4. Therefore, 1 by 1 plus x power 4 the whole square. After that, you need to tan inverse over. Now, what about x power 4? You need to apply chain rule, that you should not forget. X power 4, when you differentiate, you will get 4x cube into dx. Now, see this. Here you have x cube divided by 1 plus x power 8 into dx. But we don't have 4 here in this integral. So, we are bringing this 4 here. Therefore, dt by 4 equal to x cube divided by 1 plus this x power 4 the whole square is nothing but x power 8 into dx. Therefore, in the place of x cube 1 plus x power 8 dx, you are writing as dt by 4. 1 by 4 I am taking outside dt. Now, this term is over. Sine of, what about tan inverse of x power 4? Like tan inverse of x power 4 you have taken to be t. Therefore, you will have sine of t into dt. Integral over sine of t into dt is nothing but minus cos t plus c. Therefore, since 1 by 4 is there, minus 1 by 4 cos t plus c. Substitute the value of t. Tan inverse of x power 4 plus c. What mistake you will do is this tan power 4 you won't differentiate. That whenever you are doing, you need to apply chain rule properly. The next one, you need to take this term, the denominator term to be t. When you differentiate, you will get 10x power 9. Now this is of a power s, a power x into log a power x into log a is 10 power x into log 10. That's what the numerator. The next one, integral, they have given, they did not give one here, dx divided by sin squared x cos squared x dx. This is an important sum. You need to assume this here it is 1 into dx, that 1 can be written as sin squared x plus cos squared x, since sin squared x plus cos squared x is equal to 1. You are in the place of 1, you are writing this, after that separating the integral. Sin squared x by sin squared x cos squared x plus cos squared x divided by sin squared x cos squared x into dx. That's what you have written. After that, this sin squared x will get cancelled. Here cos squared x will get cancelled. So I have written the remaining thing here. 1 by cos squared x, here 1 by sin squared x. 1 by cos squared x is nothing but secant squared x. This is nothing but cosecant squared x. If you know the integral formula, it is easy for you to integrate and write. This is integral over secant squared x dx is nothing but tan x. Integral over cosecant squared x into dx is nothing but minus cot x. So together write the constant of integration. That is the value of the integral. Complete this exercise and upload in Google Classroom.